All right, let's take a look at the lesson 0.1.5 homework. So we've got a table here of a bunch of different substances, and the specific heats are listed for each substance. So there's some different units in this second column over. It's how many joules it takes to heat up 1 gram of this substance by 1 degree Celsius. And then same thing, there's the units for this specific heat are calories per gram degrees Celsius. So for water, it takes 4.1 joules to heat up 1 gram, 1 degree Celsius, which is the same thing as saying it takes 1 calorie to heat up 1 gram, 1 degree Celsius. It's just different units. So we can see ocean water requires a little bit less energy. Oh, I see. These are in order, actually, of requires the most energy down to iron, which requires the least amount of energy to change its temperature. So let's look at number 1. It says the table above shows the specific heat values for various substances. Explain how your calorimetry experiment would have been different if you'd used olive oil inside the can of water. So I'm looking at olive oil right here. Olive oil requires only 1.8 joules to heat up 1 gram, 1 degree Celsius. So olive oil requires less energy to change 1 gram of it 1 degrees Celsius. So olive oil would have increased more in temperature than water did. Since it's, for water it's 4.2, olive oil requires about half as much. If the water went up, let's say 25 degrees, it changed, then olive oil would go up about 50 or more than 50 degrees. On a hot summer day, would you rather stand barefoot on a sandy beach or an asphalt driveway? Okay, let's check it out. An asphalt driveway requires more energy to heat up than a sandy beach. So I would rather stand on asphalt because it takes more energy to increase its temperature. I'm just going to say to heat up to keep it simple, than sand does. So sand would get hotter quicker. The specific heat of dry air is not listed on the chart above, but it's 1 joule per gram degree Celsius. Knowing this, explain why a group who stuck their thermometer in the flame of a burning piece of popcorn had their thermometer blow up on them. Well, it doesn't take much energy to change the temperature of air compared to water, for example. So if it doesn't take much energy to change the temperature, it's going to heat up a lot more quickly, which is why their thermometer blew up. All right, number 3. How much energy would be produced per gram of cracker if the flame heats 200 grams of water from 12.3 degrees Celsius to 37.9 degrees Celsius? The cracker's mass started at 21.2 and it ended up at 17.4. All right, I'm going to give myself a little bit more space here to do this. All right, so where do we even start? I'm going to sketch a little picture. I've got 200 grams of water and I'm burning a cracker underneath. There's my flame, my flaming cracker. So I want to know how much energy was transferred to the water because the potential energy in the cracker is going to be converted into thermal energy. So I can use a little calculation formula here. The heat energy transferred to the water is equal to the mass of the water times the specific heat for water times the change in temperature of the water. So the water weighed 200 grams. The specific heat for water is 4.2 joules are required to heat 1 gram 1 degree Celsius. And what was the temperature change here? 37.9 minus 12.3 equals 25.6 degrees Celsius. That is my temperature change. So when I punch that into my calculator, I get 21,504 joules. The question is asking me how much energy is produced in joules per gram of the cracker that burned. The cracker started at 21.2 grams and ended at 17.4 grams. That's a difference of 3.8 grams. So 3.8 grams of cracker gave off 21,504 joules. So that comes out to be 5,659 joules per gram of the cracker. All right. Number 4. What is the specific heat of a 4-gram sample of a substance that's heated with 100 joules of energy and the temperature rises to 27.1 degrees Celsius? So first I got to think here, okay, I'm solving for specific heat. So I know my equation again here. Energy equals mass times the specific heat, which is what I'm looking for, times the change in temperature. So what information do I have? I know that I put in 100 joules of energy, and I know the mass was 4.0 grams. I don't know specific heat. I know the temperature change because it says it rose 27.1 degrees Celsius. So now I need to get C by itself. So I need to divide both sides by 4 times 27.1. So ultimately I'm going to punch into my calculator 100 divided by 4 times 27.1, and my specific heat comes out to be 0.92 joules per gram degree Celsius. So whatever this substance is, it takes 0.92 joules to heat 1 gram of it 1 degree Celsius. So let's scroll back up to my chart. Oh, that was asphalt, like our other question. That's the one that matches. So I'm going to go back down and answer part B here. Part B says, based on the table given, I guess it wasn't in the check-in, what material is most likely to have this specific heat? And it was asphalt. All right. Last question is about burning a cashew versus burning a marshmallow. All right. It says we've got a 1 gram sample of cashew burned in a calorimeter that has 1,000 grams of water. Okay, so there's 1,000 grams of water. Here's my little cashew on fire underneath. The temperature change went up 5 degrees Celsius because it says it went from 20 to 25. So let's figure out how much energy per gram. It was 1 gram of cashew that burned. Let's see how much energy is in a cashew. So the heat given, the thermal energy transferred from the cashew to the water, we can figure out based on what we know about water. So we're going to take the mass of the water, multiply it by the specific heat for water, multiplied by the change in temperature. So the mass of the water was, 1,000 grams of water, multiplied by The specific heat is 4.2 joules per gram degrees Celsius, and the temperature change was 5 degrees Celsius. Plug that into my calculator. It's 21,000 joules per, since it was 1 gram, it's just 21,000 joules per gram. That's how much energy the cashew has. Okay, how about the marshmallow? Well, this is interesting because it says that this time we're heating up, we're burning off 3 grams of my, I'm going to draw a mini marshmallow on fire. 3 grams burned off, and the water level is different. This time it's 2,000 grams of water, and still the temperature change is 5 degrees Celsius. Okay, so same equation here. Mass of the water, though, is 2,000 times the specific heat times the change in temperature. That comes out to be 42,000 joules was given after burning 3 grams. So 42,000 joules divided by the 3 grams comes out to be 14,000 joules per gram. So based on the data, what can be concluded about the energy content of each of the substances? So a cashew has more energy per gram, per 1 gram, than a marshmallow. That's what we can conclude. All right, and that is it for this homework.